All right, so 2.1 functions. That is the title of your notes. Homework 6 is due next Tuesday. It is from your book. We just pick up where we left off. So we had the first 5 homeworks from the first test, and now we just keep the numbers rolling. Make sure you're labeling your homework with the number. I need one of these numbers on there, not the page number, but the number. So homework 6, homework 7, etc. And most of them are in your book except homework 9 is a worksheet. All right, so did everyone pick up both handouts in the front of the room? Save us some time. We're going to glue down a few things. So before you glue down example 1, which you should have picked up, go ahead and copy down these 2 definitions. So what is a relation? A relation is just the correspondence between 2 sets. A function from X to Y is a relation where each element of X is associated with one unique element of Y. And another way that you may have heard this being worded back in Algebra 1 is that X cannot repeat. That's another way to kind of think of what a function is. So I'll give you a second to copy down that. And then pick up example 1, which you should have, which you should have, and glue it down. And we do have to share glue sticks, so after you glue it down, you might have to pass it to the left or right. Anybody waiting on a glue stick? So let's look at these examples and determine if they're functions. We're only supposed to glue down example 1 because that's the one up there, but it's okay. Didn't follow that, but okay. Yeah. So everybody glue down example 1. Okay. So Looking at A, is that a function? Okay, so we're going to look at our X values. See, these are my X values. Notice how they're all different. So that would be a yes. This is a yes. This is a function. What about B? Looking at your X values, raise your hand if you say yes. Who says no? All right, so let's look at our X values. We have a 1, a 2, a 3, and a 6. Only looking at X, not Y. Our X values cannot repeat, so that would be a yes. All right, what about C? Who says yes? Who says no? I agree, good. And it's because of these two, the ones. See how we have a 1 appear twice? So that would be a no. Okay, when you're looking at an equation, exponents on Y. So if you have an equation, you're going to look for exponents on the Y variable. If you see an exponent, then it's going to be a no. Exponent on Y. So if you notice that an exponent other than 1, I should say, or an even exponent, that's probably better. Even exponents on Y, we'll say even. Write the word even in there. So when we look at these, only one of these is a no. Don't say it out loud, but look at equations D, E, F, and G. One of them is a no, because one of them has an even exponent on Y, which makes it not a function. And that would be this one here. So this one is a no, and these 3 are yeses. All right, so now let's look at these over here. H, I, J, and K. So H, I, J. All right, for H and I are what we call maps, relationship maps. So the first oval is X. The second oval is Y. And it's telling you how the relationship is formed. So when you're looking at a map, what you're going to look for is 2 arrows coming off of the same X value. So do you notice how each one of these dots only has 1 arrow? So that would be, this is a yes. The reason why I know I is a no is because notice how in that very first one, see how there's 2? So that means that this point, whatever this number is, and let's just say, for example, that number is 5. Thank you. And we'll say that this is 1 and 2. That means that as an ordered pair, thank you so much. That means that as an ordered pair, this would be written as 5, 1 and 5, 2. Which means that X is repeating itself because that number, it doesn't matter what this number is. I just assigned a random number to it. This number in X has 2 different outputs, which makes this a no. Yes.
So for graphs, we're just looking at X. That's it.
So yeah, so the definition of a function is X cannot repeat. So now the last two, the two graphs, we're going to do a vertical line test. Do you remember that from Algebra 1? Vertical line test. When you're looking at a graph. So when I draw this vertical line, do you notice how that blue vertical line crosses through that graph one time? That means that it passed the vertical line test. So this is a function. This is a yes. But if I draw a vertical line through the circle, how many times does that vertical line go through the circle? Twice. So that failed the vertical line test, so that would be a no. So for the rest of the class period, we're going to talk about domain. So there's two objectives for today. The first objective was determining if a graph is a function. So we talked about order pairs, how to know from a set of ordered pairs, how to know from looking at an equation, how to know from a relationship map, and how to know from a graph. So now let's talk about domain. So this would be the second handout that you picked up. Go ahead and glue that down, and then we're going to talk about it. It's your notes, whichever way you want. There is no wrong way to take notes, Kimmy. You need a glue stick, Emma? Kimmy, can she use your glue stick? So domain is your X values, range is your Y values, and we're going to talk about finding the domain. Finding the domain. So, all functions, we all start off with all real numbers. Okay, so we're going to start with all real numbers. And I like to say we look for two red lights. And I did tweak this just a little bit. You might want to write this off to the side. But unless you see one of these red lights, we stick with all real numbers as our domain. The first red light is a variable in the denominator. So variables in the denominator. If you see that, and again, you might have to write this off to the side. I just tried to summarize it to make it even more student friendly. So if you see a variable in the denominator, it is not all real numbers anymore. So let's look at this one here. Let's zoom in on that first example. Variables in the denominator. Your denominator cannot equal 0. It is impossible to divide by 0. So if you have a calculator near you, take 7 and divide it by 0. If you try to divide a number by 0, it's going to say domain error. It could say non-zero denominator or something. You cannot divide by 0. So when you see a denominator with a variable in it, and I'm not saying, so if this said f of x equals x minus 2 over 3, that would still be all real numbers. That's okay. It's the x plus 3 that makes it a red light. So what we're going to do is take your denominator, which in this case is x plus 3. X plus 3 cannot equal 0. And if x plus 3 cannot equal 0, that means that x cannot equal negative 3. So we have to say that the domain is all real numbers except for negative 3. So what I'm going to do is make a little number line, negative infinity to infinity, and then I'm going to write my negative 3 here. So I would have an open circle on the negative 3, and I have 2 intervals. So my domain would read negative infinity to negative 3. I got to make a break. Union negative 3 to infinity. And we're going to practice this. I'm just introducing it a little earlier. And then we're going to do about 9 questions together, and then that's it. That is how you would write the domain. It is no longer all real numbers. The second red light that we look for is what we would call a square root. A square root, not a cube root. If this was y equals the negative 2 cube root of x minus 5, that has a domain of all real numbers. That is okay. It's a square root that is a red light. When you see a square root, we have to set the radicand, which is what's underneath. So this negative 2 goes away. We take this, and it's greater than or equal to 0. Go ahead and solve that inequality and write it in interval notation. So now we're going to do some practice. We're going to look at some functions together, and we're just going to practice finding the domain. So take a minute and copy down these 3. So do we have any red lights? Anything that's preventing this from being all real numbers? Do you see a denominator with an x in it? Do you see a square root? So you're a square root? Okay, so your domain is all real numbers. All right, question B, do you see a denominator?
No.
Do you see a square root? No. We have a square, but not a square root. So again, our domain is all real numbers. Now C, we do have a square root. So when you see a square root, you take what's underneath and set it greater than or equal to 0. Go ahead and solve that for X. You do get a fraction, and then write it in interval notation. So we have X is greater than or equal to negative 2/3, which would be negative 2/3 to infinity. And that would be my domain. Any questions about the first three? All right, let's do the next three. Go ahead and copy them down. All right, so let's look at this first one. Again, whenever you see a denominator, you're going to focus in on your denominator. This is my red light. So this cannot equal 0. X minus 1 cannot equal 0, which means X cannot equal 1. So my domain is going to be from negative infinity to 1, union 1 to infinity. So whenever it cannot equal, when you have a denominator, we have no brackets. And this would be my denominator. Not my denominator, so my domain. This is my domain. For question E, though, we have a quadratic, which simply means that we have more than one number that we have to exclude. So x squared minus 9 cannot equal 0, which means that x squared, we're going to add the 9. And when we take the square root, we get plus and minus 3. X cannot equal positive or negative 3. So I'm going to graph this one out so you can see it. So there's actually going to be 3 pieces to your domain. We start at negative infinity, we go to -3, we got to stop. And then we go from -3 to 3, we have to stop. And then we go from 3 to infinity. So my domain is negative infinity to -3 union, -3 to +3 union, +3 to infinity. There's 3 pieces to our domain. All right, question F. So we kind of combine 2 red lights into 1. What happens when you have a square root in your denominator? All right, we still have to write it as an inequality, but because it's in the denominator, it can't equal 0. It's just greater than 0. Now, if it were the other way around, if that was in the numerator, then we would put this equal and we would include a bracket. But because it's in our denominator, it cannot equal 0. It has to only be greater than 0. So we have 2 restrictions. It can't equal 0 and it has to be greater than 0. So when we solve that, our inequality is x is greater than -5. Which again, if you put that on the number line, -5. I have an open circle and it's greater than. So that means it's going towards positive infinity. So my interval would say -5 to infinity. And that is my domain. All right, we have 3 more and we are done for today. All right, go ahead and copy down these 3 and we will end there. So for G, do we have a red light? Yep, we have a square root. So let's talk about it. I want to make sure you understand that this 2, we do not care about. And this -5, we do not care about. The only thing that controls the domain is what is under the square root. This is why we have the red light. So we're going to take that -4x plus 1, set it greater than or equal. It can equal because it's not in the denominator to 0. Solve that for x. The rules of solving an inequality still apply. If you divide by a negative, you still flip your inequality. So go ahead and solve that for x. You do get a fraction, leave it a fraction. So you should get x is less than or equal to 1/4 because I have to divide both sides by -4, which means I flip my inequality. So on the number line, starting at 1/4, which has a closed circle, is less than, so that means I'm coming from -infinity. So my interval would be -infinity to 1/4, and 1/4 gets a bracket. H, do we have a red light? Nope. So what's my domain? What's our domain for H? All real numbers. No red light, nothing to stop us or hold us back. So that is our domain. And for our last question, you have 2 equations. We have to set them both equal to 0 because we have to take them both out. So x plus 1 cannot equal 0, and x minus 4 cannot equal 0. Go ahead and solve them. And again, we have 3 pieces of our domain. All right, so our domain is -infinity to -1, union -1 to 4, union 4 to infinity.